Hi, my name is Seth Schneider, and I'm a software engineer here at Intel. Today we're going to be looking at the Intel Graphics Performance Analyzer's Platform Analyzer in more detail. If you're new to GPA, I'd recommend checking out some of our introductory videos and our workflow videos linked in the description below. In this video, we'll be focusing on the CPU-bound offline analysis portion of the workflow. We'll assume that we've already captured a trace from our application, and we're ready for offline analysis. So, let's start with opening Platform Analyzer. Today we will be diving into the offline analysis portion of the GPA workflow. I have captured a trace from the 3D application City Racer and plan to analyze it using Platform Analyzer. So let's get started. First, let's open Platform Analyzer. Once the application loads up, you'll notice a list of traces on the left-hand side. Let's open a trace that I recently took. Once the trace finishes loading, you'll notice a few different windows. The main window displays a timeline with all the data in relationship to the time. Notice that the duration of the trace is 5 seconds long. This can be modified in the Profiles section of the graphics monitor. All this data can be very overwhelming at the 5-second high viewpoint. So let's zoom into a smaller piece of the trace. If you click and drag out a window using your left mouse button and then releasing, you can zoom into that selection. Let's zoom in one more time and get about 3 frames worth of data. Now that we have 2 to 3 frames worth of data, let's go over each of the columns. First, we have the frames column. Here you can view individual GPU and CPU frame timings. You'll notice that the colors correlate to the same GPU and CPU frame. For example, this purple frame here, frame number 224, is the same frame as this GPU frame here, and also frame 224. We can look at the individual durations, as well as calculate the difference of when the CPU frame started to when the GPU frame started. Next, we have the render and GPGPU queue. If instrumented with ITT, these render and GPGPU tasks will not be labeled as unknown, but have the actual call names. How this works is that everything above the dotted line is currently executing on the GPU. Also, you may notice these red hashed tasks. These are the present calls. So you may trace a present call from when it originated all the way down to execution. You'll notice that when the present was executed is when the GPU frame is finished. This is helpful in also calculating single frame latency, for you can see when the present call was submitted by the CPU and when it completed by the GPU. Now if we go to the next pane down, we have our threads pane. City Racer is primarily a single-threaded application. So in these rows, you can view when the thread was running, when the OS needed to switch contexts, and when there was synchronization. In addition, you can see the GPU work overlaid on the thread. This can help correlate between when the GPU is busy and when the CPU is busy. This can help you identify if the workload is GPU or CPU bound. In addition, you can view each of the DirectX API calls as well as user-defined calls if available. Below the thread lifetimes rows, there is the platform metrics rows. The 4 metrics recorded here are the metrics we set up in the HUD profiles. If the trace was taken in System Analyzer, then the metrics displayed here would be the metrics in System Analyzer at that time. Next, at the very bottom, we have the statistics pane. The statistics pane will update to synchronize with your selection. Depending on what is selected, this pane will display GPU usage, OpenCL kernels if you're using OpenCL, or tasks such as user-defined functions using ITT, or DirectX calls. This can also be helpful when identifying hotspots in certain areas of a trace. For example, if we highlight this section, we will notice but the tasks that the statistics area will have changed. We can see the task time per the selected area, the GPU time, and the GPU queue time. Last but not least, we have the legend area. Since Platform Analyzer offers such a plethora of data, it is sometimes helpful to turn off certain sections in order to make the UI less complicated. It's just as easy as unchecking a checkbox to remove a section. For more information regarding each of these sections, please visit our documentations at intel.com. Thank you for taking the time to learn about Platform Analyzer. If you have questions, be sure to post in our forums on the Intel Developer Zone website, or you can check out our support pages linked in the description below. To learn more about the other components in GPA, be sure to check out our other tutorials. Thanks for watching.